Welcome back, everybody. Today we're going to talk a little bit more about polar coordinates, and we are specifically going to talk about area and arc length in polar coordinates. Now, this is much more of a calculus topic, hence it will not be cross-post to pre-calculus like my initial polar coordinates post was. However, if you need additional support with plotting a point, graphing, converting a point from polar to rectangular or back again, you should definitely seek out my first post on polar coordinates. It gives you more of the basics. All right, again, these are mini lessons, so I am not necessarily going to do all the math necessary, but I am going to show you a little bit. All right, so let's start with area. Area of a circular sector, you may have learned in pre-calculus, is 1/2 r squared theta. R is the radius of your circle, and theta is the central angle in radians. All right. Now, to convert to polar and get area equals the integral from a to b of 1/2, and again, it's r squared, not theta, but d theta. And again, r is your polar equation. So let's just jump in and knock out a couple of examples. So let's start with example 1, which is find the area of one petal of the rose curve given by r equals 3 cosine 3 theta. All right, so again, we're going to use that formula right above. Now, all right, so if we start filling in our spots, we have area equals the integral from a to b, 1/2. R squared is going to be right here. So it's 3 cosine 3 theta squared d theta. The only thing that's really missing is our limits of integration. Now, other people may know better ways of getting this. I think the best way to get this is to sketch a quick graph of 3 cosine 3 theta. Now, obviously, you need some graphing skills, but if you graph it, you will realize that that one of the petals starts at negative pi over 6 and ends at pi over 6. And I would get this by making an r theta chart and start plugging in values. You'll notice that if you plug in negative pi over 6 right into your r theta chart, you would get 0, and pi over 6 you would also get 0 with points in between. So we have our problem set up. Now the question is how to do it. All right, well, the first thing I can do is this. I can take my 1/2 out of my integral, and I'm going to square that. So it's 9 cosine squared 3 theta d theta. All right, so if I'm going to do the integral of cosine squared, let's see. So there is a trigonometric formula to use. I'm going to shrink that a little bit. So I have cosine squared u equals 1 plus cosine 2u divided by 2. So in order to do the integral of cosine squared, I need to use my half angle formula. First thing I'm going to do is I'm going to take the 9, since it's a constant, and I'm going to take it out of my integral. So I have area equals 9 halves, negative pi over 6 to pi over 6 of cosine squared 3 theta d theta. Now, do you have to move all of your constants out? Certainly not a requirement, but for my taste, I like less clutter around my integral. It helps me out a lot. So now I need to use this formula here. Area equals 9 halves, negative pi over 6 to pi over 6. And I have 1 plus cosine. Now I'm putting 3 theta in for u. So 3 theta times 2 would be 6 theta divided by 2. All right, and once again, I have a constant. I have a half here that I can pull out. So I have area equals 9/4 negative pi over 6 to pi over 6 of 1 plus cosine 6 theta. And now I'm ready to integrate. So at this point, I'm going to ask you to stop the video, and I'm going to ask you to try to integrate, and we'll talk about the answer on the back end. All right, so hopefully you paused the video and integrated. So I got area equals 9/4. Now if I integrate 1, it's going to be theta. So I'm going to have theta plus, and then the integral of cosine 6 theta is sine 6 theta divided by 6. And that goes from negative pi over 6 to pi over 6. A lot of teachers will have different opinions on this. My general opinion is that I really do, I don't necessarily need to see every step along the way for the integral. I teach Calc 2. In Calc 2, I definitely need to see every step along the way. I just need proof that you integrated. So as much or as little as you need to write is fine with me. But like I said, other teachers may have differing opinions. You should definitely ask your teacher how much work you need to show. So I'm going to run my pi over 6 and negative pi over 6 through, and I wound up with 9/4 times pi over 6 plus pi over 6, and I got 3 pi over 4. All right, so that is a more basic one. That's a fairly standard opening problem to deal with. Let's step it up a notch. I've got a slightly more difficult one to deal with. So example 2. We want to find the area of the region lying between the inner and outer loops of the limacon r equals 1 minus 2 sine theta. All right, now once again, in order to understand the problem, I think you need to graph r equals 1 minus 2 sine theta. That definitely takes time. So if this was going to be on an assessment, I most likely would have a part A and a part B. The part A would be graph the limacon, and part B would be find the area between the inner and outer loops. which I've used on a quiz before. But I definitely think that's the best way to understand where the inner loop begins and ends, where the outer loop begins and ends. All right? So if you were to graph this, you would realize that the inner loop begins and ends at pi over 6 and 5 pi over 6. Again, I'm not going to spend time to graph it, but I am going to start my integral. 1/2 the integral pi over 6, 5 pi over 6 of 1 minus 2 sine theta, the whole thing squared, d theta. All right, now this is a little bit different. We have a little bit more algebra to deal with before we get to the integral. So you need to take this piece right here and you need to expand and FOIL it. All right, so I'm going to ask you at this point to pause the video and let's expand and FOIL that, and we'll talk about where to go afterwards. All right, so hopefully you paused the video. If you did, you got 1/2 the integral from pi over 6 to 5 pi over 6. And I got 1 minus 4 sine theta plus 4 sine squared theta d theta. And in order to integrate sine squared, we need to remember a trig identity, which is that sine squared u equals 1 minus cosine 2u divided by 2. So you're going to need this in order to help you integrate that. So you need to make that substitution. All right, so go ahead, pause the video, make that substitution, and then we will see where we go from there. All right, hopefully you made the substitution. So I got area equals, and I did a little bit of extra algebra, so pi over 6, 5 pi over 6, and by doing a little bit of extra algebra, I'm left with 3 minus 4 sine theta minus 2 cosine 2 theta d theta. Now notice we have not integrated yet, but please make sure that your problem and mine are in the same spot. All right, at this point, all right, you are ready to integrate. So pause the video, do the integration, and then we'll see where we're at on the back end. See you soon. All right, hopefully you integrated. And I think I missed a 1/2 over here, so I'm going to just stick that in. So I got equals, again, the 1/2 is there. I got 3 theta plus 4 cosine theta minus 2, actually not minus 2 sine 2 theta, just sine 2 theta. From pi over 6 to 5 pi over 6. And when you run your first fundamental theorem of calculus, I got 1/2 2 pi minus 3 radical 3, and this equals the area of the small circle. All right, and you can further simplify this by distributing your half. So I get pi minus 3 radical 3 over 2. And this, again, would be my final answer. And it is, again, the area of the smaller circle. Now, the thing we need to do is this. Now we need to find the area of the larger circle, right? We find the area of the larger circle, and then we subtract the two, and we should get our answer. All right, so this problem gets extended. So now the larger circle, the limits of integration are going to be from, we start at 5 pi over 6, where our small circle ended. And if you were to graph it, you would see that the large circle ends at 13 pi over 6. All right, now we're going to set it up the same way. 1/2, 1 minus 2 sine theta, the whole thing squared, d theta. And we already executed this integral once. Now I'm going to ask you to do the work again. All right, and put in your upper and lower limits. And I'm going to call this area 2. So pause the video, do the work, and let's see what area 2 is. All right. So I got area 2 to be 2 pi plus 3 root 3 over 2. And now we need to do area 2 minus our first area, which equals 2 pi plus 3 root 3 over 2 minus pi minus 3 root 3 over 2. And I got 2 pi minus pi equals pi. And I got 3 root 3 over 2 minus negative 3 root 3 over 2 is plus 3 root 3. And if you had a calculator or needed a decimal equivalent, it would be 8.34. For my class, I would take that as an acceptable answer. All right. So let's take a quick look at arc length. And maybe we'll just try one example. So for arc length, we have the integral from a to b of the square root of r squared plus the derivative of r in terms of theta squared d theta. This is your formula. All right. So we'll use that formula, and here's the example. Let's try. Find the arc length of the cardioid from 0 to 2 pi. The arc length of the cardioid from 0 to 2 pi, and it's r equals 2 minus 2 cosine theta. Now, for this one, you don't necessarily need to graph, all right? Because right in the problem, I'm giving you your limits of integration from 0 to 2 pi, all right? So let's start setting up our formula. S is the letter we use for arc length, so I'm going to go from 0 to 2 pi. I'm going to do the square root of 2 minus 2 cosine theta squared plus, now I'm doing the derivative of that. So the derivative of 2 is 0. The derivative of negative 2 cosine theta is 2 sine theta, and I'm squaring that as well. Now, before I integrate, I sure would love to simplify this if I could. All right, so I'm going to integrate from 0 to 2 pi because integrating under a radical symbol, tough enough. So the first thing I'm going to do is this, you need to expand and FOIL. All right, so when you expand and FOIL it, I got 4 minus 8 cosine theta plus 4 cosine squared theta. And then I'm going to square the other term, which is plus 4 sine squared theta. All right. So now, what do I see? Well, over here, I have a common factor of 4. So if I were to, 0 to 2 pi. So I'm going to leave the other two alone, 4 minus 8 cosine theta plus 4 cosine squared theta plus sine squared theta. Now we know from our trig that cosine squared theta plus sine squared theta equals 1, which means now I'm left with 0 to 2 pi, the square root, and so here I'm just left 1 times 4 is 4, plus 4 is 8, minus 8 cosine theta. All right, now I can pull the 8 out of my square root symbol, can't I? Right, so I'm left with, 2 radical 2, the integral from 0 to 2 pi of 1 minus cosine theta. So you see, doing some algebra to work this down a little bit is indeed helpful. All right. So now this integral is a little bit tough. All right. So we're going to think a little bit. Now, if I were to use sine squared theta equals 1 minus cosine 2 theta over 2. All right, well, let's think about this for a second. I have 1 minus cosine theta. So if I were to, let's say this was over here, then I could backtrace a little bit, right? Use the formula backwards and say 2 radical 2, the integral from 0 to 2 pi. And I would have the square root, and under that square root, I'd have 2 sine squared, not 0, but theta over 2. All right. So again, I have a radical 2 over here, so I'm going to bring that out. So I have 2 radical 2 times radical 2, 0 to 2 pi, and I'm left under the square root with sine squared theta over 2. And if I take the square root of sine squared theta over 2, all right, so, well, first I can take my constants, and I have 2 times 2 is 4, 0 to 2 pi. If I take the square root of that, I will have sine theta over 2. Now I can integrate. All right, so I'm going to ask you to pause the video, do the integration, and I'll let you know what the answer is on the back end. All right, hopefully you paused the video and were able to do the integration. I got a final answer of 16. So that would be your arc length between 0 and 2 pi. Now, very typically, I will give a fairly standard problem like that. The integration, including the algebra, is tough enough. But hopefully you got a little bit out of this. I would definitely endorse more practice. But thanks, guys, for listening, and I'll see you soon. Have a good day.